So in order to share the resources among multiple processes, we must have a synchronization. That means when one process is allowed into the system, no other process is allowed to access the data item. The section which is shared among different processes are called as a critical section. Semaphore is a tool that helps you to change the value from 0 to 1 and 1 to 0. Hello and warm welcome to one and all. It is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, let me talk about the process synchronization. What is the meaning of synchronization here? Synchronization means there is a communication. If there is a communication or interdependency between one process with another process, then it is called as a synchronization. Suppose if such synchronization happens between two processes, then we say that it is a process synchronization. If that is the case, let me explain about the process synchronization. That means, process synchronization means sharing system resources by processes in such a way that concurrent access of shared data is handled, thereby minimizing the chance of inconsistent data. Let me explain this paragraph in detail now. Suppose if there is a process P1 and process P2, and if there is a data called data section wherein we have the value which is equal to 10. Now let me give access to this data section 10 to process P1, so that process P1 fetches the data 10 and increases the value of data by 2. 10 plus 2, that is equal to 12. Which is the updated data? That is 12 is updated here. And it writes the value 12 in turn into this position. That is not 10, it is 12 is written over this. Next time, if I give access to process P2, what is the value that is given to this process P2? It is 12, not 10. Because if I give access to the both of these processes, process P1 as well as process P2, what happens? Process P2 may fetch this data 10, and 10 plus 3 is what? That is 13. Because 3 is the value that it wants to add in process P2. 2 is the value that wants to be added in process P1, so that it gives an inconsistent data, that is 13 is given to it. If that is the case, what has to be added here? 3. So 12 is given to it. 12 plus 3 is what? 15. So obviously what is the value it is expecting? It is expecting the value 15 into it. So what happens if I give access to both of these at the same time? At the same time, it gets the value 10. Both of these gets a copy of this value 10. So there is a chance of getting an unpredicted data because of the shared access to this data item. So in order to share the resources among multiple processes, we must have a synchronization. That means when one process is allowed into the system, no other process is allowed to access the data item. That is called as a synchronization, understanding between two processes, that is carried out here. So if that is the case, maintaining data consistency demands mechanisms to ensure synchronized execution of cooperating processes. What is the meaning of cooperating processes here? If there is a dependency from one process to another process, then we state that there is a cooperating process that has got some certain types of dependency between each other in terms of data items. That is the reason we say that the consistency of data items is very, very important in case of synchronization. The reason for employing the process synchronization is to maintain a consistent data in the shared resources. Otherwise, it may lead to an inconsistent data item. So if that is the case, there are three different types of problems you will come across in case of synchronization problem. First one is the critical section problem. Second one is readers writers problem. The third one is dining philosophers problem. What is the meaning of critical section problem? The section which is shared among different processes are called as a critical section. And this shared data must be allowed to access only the appropriate processes, so that process P1 can access the data item. At the same time, process P2 is not allowed to access the data item. so that there must be some consistency of sharing of data between process P1 and process P2. That is the meaning of critical section problem. Suppose if any axis is given there, then that leads to an inconsistent data. That is the reason we call it as a critical section problem. What is the meaning of readers writers problem again? Suppose when reader R1, that means we have R1 and R2 are the two processes, or process P1 wants to read and process P2 wants to read as well as write. In such cases, what happens? Process P1 can only read the data, but it cannot write anything into it. That means if it has got a value 10, it can fetch the data into it, but it cannot update the data into the section, that is to this section. Then process P2 has got the permission to write. If that is the case, 10 is fetched there, 10 plus 20, that is equal to 30, that finally it has the permission to write, so it writes the value 30 into it. So what is the updated value we have here? 30, not 10. But so the 30 can be read into the process P1. So because the readers and writers problem can be allowed here, that means if two writers are allowed to perform the axis of data at the same time, again that leads to an inconsistent data. So we need a process synchronization there. That is why we have the readers writers problem. We also have a solution to it. Then which is the third type of problem, that is the dining philosophers problem. There are 5 philosophers sitting here, and each of the philosophers are having 2 chopsticks. Their job is to think and eat, that's all. So if that is the case, when one of the dining philosopher picks 2 of these, the other will be shared by this. That means he has to share the same chopstick. That means at the same time we cannot give access to each of this, because we have 2 chopsticks here. This chopstick belongs to this, and at the same time he wants to access the same chopstick. So that leads to a problem. So we have a solution to this dining philosophers problem in an alternative manner. That is the problem of dining philosophers problem, and alternatively we have a solution to this problem also by the method of synchronization, process synchronization. If that is the case, the first one is critical section problem. Let me explain you the critical section problem now. Critical section is a code segment that accesses shared data variables and has to be executed as an atomic action. What is the meaning of atomic action here? Whether the transaction is successful or none. That means if there is any updation to be done, that is successful to it, or else no updations are done to that data section. So there is a code called segment that updates the shared data. The shared data means the data section which is shared among multiple processes. So if that is the case, we have to keep a consistent data in the data section. So we have to protect this data section from the 3 processes. Then only we can synchronize. When we can synchronize, allow this process P1, when we can allow this process P2, when can we allow this process P3, so that when one of the process is executing, no other process is allowed to execute. When one process is executing, no other 2 processes are executed, are allowed to access. That is called as a critical section. So it means that in a group of cooperating processes, at a given point of time, only one process must be executing at its critical section. That is, in this critical section, only one process may be allowed to execute in the critical section. If any other processes also wants to execute its critical section, it must wait until the first one finishes. That means if any other processes like process P2 and P3 wants to access the data item, these 2 processes must wait until P1 completes the execution of this data item. That is the thing here. Please see to it in the diagrammatic representation. This is called as an entry section. This is called as an exit section for this critical section. This is very, very important. This is called as a critical part. Now we have, when the control enters this entry section, it locks the section. It locks this section for process P1. For this process P1. So that no other processes are allowed to enter into this critical section. When it enters into an exit section, that means it releases a lock. It releases a lock that it unlocks the critical section. So thereby P2 and any other processes who wants to execute this critical section may be given access to this critical section. So that means what? Only one process at a time can access the critical section, that is to the shared data. The shared data, the alternative name for critical section is shared data. That is the meaning of this. There is a three conditions the critical sections must satisfy. The very first condition is mutual exclusion, also called as mutually exclusive. That means what? Mutual is also there, exclusive is also there. When two processes wants to execute, only one process can be in its critical section at a given point of time. That means when two processes or cooperating processes wants to execute the shared data, we will not allow those processes to access the shared data. We will allow only one process, either process P1 or process P2 or process P3 or so on up to process N. That is called as a mutually exclusive property. Exclusively for process P1 or for process P2 or anything, but only one process is allowed at a time. That is the meaning of it. What is the meaning of progress? When no process is in its critical section, that means no process wants to access the shared data. If one or more threads want to execute that critical section, then any one of these threads must be allowed to get into its critical section. You know that each process may have n number of threads, but all these threads are waiting for a critical section. If when two or more threads or one or more thread wants to access the shared data, we want to allow only one thread at a time to access that. That is called as a progress. Then we have the third condition, that is bounded waiting. Waiting is bounded. That means what? For a definite time, not for an indefinite period of time. It waits for a definite time to complete the accessing of data items by any of the processes. If that is the case, after a process makes a request for getting into its critical section, there is a limit for how much other processes can get into their critical section. That is, what is the amount of time that other processes are allowed to wait so that the process P1 can complete the execution of it. That is called as before the process request is granted. So this is called as bounded waiting. The word bounded indicates that a limited time of waiting. The limited time of waiting is allowed to execute any of the data items by any of the processes. That means what? The ultimate condition here is to allow only one process to execute or access a data item at one point of time. That is called as a bounded waiting. So these three conditions must be satisfied by any of the critical section problem. Next we have semaphores. What is the meaning of semaphore? We have a data item. There are two different types of semaphores for process synchronization. Dijkstra proposed a significant technique for managing concurrent processes for complex mutual exclusion problems. He also introduced a new synchronization tool called semaphore. What is the meaning of semaphore? Semaphore is a tool that helps you to change the value from 0 to 1 and 1 to 0. That is the only one thing. This is called as a binary semaphore. There is an alternative, another semaphore called counting semaphore. What is the meaning of counting semaphore? We have 0, 1, 2, 3, so on like that n. When 0th process is executing the critical section or data section, no other process are allowed. When first process is executing in the critical section, no other process are allowed to execute in the critical section. That is called as a counting semaphore. We will assign a process ID. We will assign the semaphore value to these process IDs so that only one process is allowed to execute in the shared data section or in the critical section. That is the meaning of that. So we have two different types of semaphores here. One is binary semaphore and the other one is counting semaphore. Moving on to the binary semaphore, we will be having a special form of semaphore used for implementing the mutually exclusive property. When one of the system enters into the critical section, we will set it to 1. that means we change it from 0 to 1, and when it exits the section, we change the value from 1 to 0. That means no other process is executing the critical section. That is the indication of that. In case of binary semaphore, that means 0 and 1 are the values I am using there. In case of counting semaphore, these are used to implement bounded concurrency. That means when multiple processes wants to execute, we will allow only the processes which are in need of data section by assigning certain types of counting values varying from 0, 1, 2, 3, so on up to this value. So we will call this as what? When 0 is indicated, we say that process P0 wants to execute. When 1 is there, we say that P1 wants to execute. Similarly for P2, P3, P4, so on up to Pnth problem, that is the nth process is permitted to execute the data section. This is how the types of semaphores are used. This is provided by Dijkstra. So with this, I am going to conclude this session. If you have any questions, kindly come to college. I will be available here to clear your questions and doubts. Thank you very much. Thank you one and all.